I'm going to be using test-driven development to explore the design needed to convert integers into Roman numerals. I am in Eclipse. On the left-hand side, I've got the specification. On the right-hand side, I've got production code. At the bottom, I've got Jasmine's showing I'm on all green. There's some example code just to make sure the setup works. So I'm going to start by adding a describe for Roman, and the first test will be the integer 1. I'm going to be using an object, so the first step is to create that object, and immediately we're on red. So I'll go to the production code and add the code needed to bring us back to green. I'll be returning some Roman string and using an int to Roman helper method with the integer 1. The moment I've done that, we're on red. I'll add that helper method to get us back to green. I'm expecting the Roman string to equal Roman numeral 1. Immediately we're on red, and we'll simply return Roman numeral 1 to get us back to green. Notice that I'm not designing at the moment. I'm just exploring the design by adding specifications. So let's add integer 2. And immediately we're on red. The simplest code that I can add to get us back to green is to test for value and return Roman numeral 1 if it is equal to 1, else I'll be returning Roman numeral 2. And we're back on green. And we're going to continue doing this. Now that we're on green, we can start to see a pattern emerge, and only while on green we'll refactor and we'll make it a bit prettier. So we'll add a Roman string variable. We'll set it to nothing. And we'll replace this with a while loop. So while value, let's reduce the value in the loop. We'll just add Roman numeral 1 every time we pass the loop until value is 0, and we'll return Roman string. Now we've refactored the code and we're still on green. So now that it looks a bit prettier, we can add a test for integer 4. And we're on red. And we'll test if it's 4. We'll set Roman string equal to Roman numeral 4, and we'll subtract 4 from value, and that should make it pass straight through, and we're on green. And we continue doing that for integer 5, and we're on red, and we'll copy this and add it and we're now on green again. Now it's ugly, but the design is not revealing itself to me just yet, so I'm going to continue, rather not think about it too much and just keep on adding tests and see what happens. And let's continue with 10, adding 10 in, 10, expecting Roman numeral 10, and we're on red as expected, and we're going to test for 10, 10, and we're back on green. Now that we're back on green, no, I am going to continue with 11. I can start to see a pattern emerge here, but it feels a bit early. So I'm going to add 11. We're on red. Now similar to 5, I mean, this is feeling familiar, so make it greater or equal to 10. And we're on all green. Now if I look at this code, there is a definite pattern with 4 and 5 and 9 and 10 as the boundary conditions. And if I look at Roman numeral 10 and I'm subtracting 10, Roman numeral 9, I'm subtracting 9. Let's simplify this code by capitalizing on the pattern that's emerged. We're going to refactor, we're allowed to refactor, we're on all green. And to do this, I'm going to add a variable Roman digits. So Roman numeral 10 will be decimal 10. Let's just stop there. And I'm going to iterate over this variable and subtract the decimal equivalent. So 4 digit in Roman digits, whoops, while value is greater or equal to the decimal equivalent. We're going to add the Roman numeral to Roman string, and we're going to decrease the value with the decimal equivalent. Now notice that the amount of design thinking I've done here is very limited, because I'm simply echoing what has emerged here in code, and it's exactly what's down here. Now this should be enough to test whether I'm on the right track, and we're still on all green. So I can remove this, and we're still on all green. So now one by one I can refactor these if statements out, and every time I'll make sure that we're still on all green, and we're still green. So in complete safety we managed to refactor out all the if statements, and we now have something that's starting to look attractive. And now we can continue. Now on this side, this is also a bit ugly. So we are on green. So let's try and refactor our test code as well, just to make it a bit prettier. So the object, we can use an object common to the entire describe, and we're still on green. Similarly, with the Roman string, we can define it once, that's enough. It's also a bit cleaner. And we're still on green. Now, just like I refactored the production code in safety, I can do the same with my test code. Refactoring test code is just as important as refactoring production code. So a pattern has emerged here as well. We've got a decimal equivalent and a Roman numeral value, and we can set up a series of test values and then just iterate over them. So if we say test values, so we'll start with Roman numeral 1, and just before we go too far, we just make sure that everything will work. So we're now going to rename this to, we're going to test int to Roman, and for value in test values, we're going to pass the value in, and we're going to expect test values. So let's see if that still works. That still works. And now we can simply build a list of test values. Now that the test code has also been refactored and looks a lot better, I'm just going to do a sanity check and make sure that I'm not fooling myself. And yes, sure enough, if I force a failure, it shows that failure. So now I can start exploring how far this design will hold. So let's test the value 15, and that still passes. Now this should be the entire integer to Roman numeral. So let's test it with the maximum that Roman numerals can support, and that's 3999. So that will be 3 M's for 3000, then CM for 900, XC for 90, and IX for 99, and it passes. And we have successfully written, with test-driven development, a integer to Roman numeral method that fits in 20 or so lines. If we compress it, it will be much less than that, and it's an eloquent design.